heater. I mean, like, I don't have any portable heaters. Okay, so we're talking about the function f of x equals 2/3 x plus 4. And we're told that it's a linear function. It can also be written as y equals 2/3 x plus 4 instead of f of x, right? We know that f of x and y are the same thing. So we have to find the value of f of 9. How do we do that? Okay.
So that means that becomes f of 9 equals 2/3 times 9, which will be in parentheses, plus 4.
I love that. Let's see. 2/3 times 9, that's the same thing as saying 9 over 1. How do we multiply fractions? Straight across. So f of 9 equals 2 times 9 is 1 times 3 is
Which eventually equals 6.
it does equal 6. So f of 9, 18 divided by 3 is what Owen is saying equals 6. Is 6 plus 4. So f of 9 is, okay. Your warm-up is one of the piles of stuff that you were given from me. You should probably get that. It's a half sheet of paper, Tyler. I know with your stuff. My secretary did that for me. I think Ariana was the secretary that day. Okay. So it says fill in the table below for this function and plot the coordinates. Plot and connect the coordinates. That's what it says. I made the graph big so we could plot easier. So what is an easiest way to get a table of values for this? Calculator. Everybody pick up your calculator and go to y equals. Pick up your calculator and go to y equals. What are we writing?
2/3 x, 2/3 parentheses 9 plus 4.
So calculator. We're going to the y equals button. And we're typing parenthesis 2 divided by 3. Close your parenthesis. Throw an x there. Plus 4. That's what I want you to write. And then what are we doing? Second graph. Yeah, you're going to press the second button and the graph button. The second button and the graph button. So, does anybody notice anything weird about the x values that are given to us?
Well,
the x's on the table.
They're super large numbers.
No.
Oh.
The x's on the table. What are they? What kind of numbers? Those aren't all positive. I'm talking about right here. You guys see these x values? We're just finding the output when x is -3, 0, 3, 6. They're multiples of 3, right? Why? Because the function has a fraction in it, 2/3. And we know that if we multiply 2/3 by 3, the denominators cancel out. So it's because we want to have nice whole numbers to graph. That's why. We want integers. We want nice integers to graph. So when x is -3, what is f of x? 2. When x is 0, what is f of x? When x is 3, f of x is. When x is 6, f of x is. And when x is 9, f of x is. Okay, so it says to plot your points, and we're going to connect them with a line because this is a linear function. So we're going to connect them with a line. So let's see, when x is 2, when x is -3, y is 2. When x is 0, I'm at 4. When x is 3, I'm at 6. When x is 6, I'm at 8. And when x is 9, I'm at 10. So when I connect my points with this nice, fabulously straight line, we're going to talk about a couple of things that we discussed yesterday. Yesterday on our journal, we said that the number that you multiply x by stands for what?
The slope.
Yeah, this is my slope. Let's check. That means that I'm going to go up 2 and to the right 3. Let's see, to go from this point right here to this point, how much do I go up?
You go up 2.
And how much do I run to the right?
You run to the right by 3.
Perfect. What if I started at this point right here and I went all the way up and to the right? How much do I go up here?
Go up 4.
And how much do I go to the right?
6.
4 over 6.
It can equal 2 over 3.
Yeah, it reduces to 2 over 3. Very good. Okay, so this little box underneath the outputs is just asking us for the ordered pairs. So we're just going to write the ordered pairs. -3, 2. This is the ordered pair 0, 4. There's something special about that ordered pair. I'm waiting for someone to tell me what's special about that ordered pair. What did you just whisper, Ken? Did Ken whisper that first? Who whispered that? Ken, look at my face. Did you whisper that? Who whispered it's the y-intercept? Was it you, Aiden? Okay, it is the y-intercept. I'm going to highlight this. We know it's the y-intercept without looking at the graph. Why?
Because x is 0.
Yeah, the y-intercept happens when x equals 0. That's super duper important. So here's this word that we all love in question C. It says in the table, what is the average rate of change between any two consecutive values? So let's figure out the average rate of change from -3 to 0. And then we'll figure out the average rate of change from +3 to 9. Do we remember how to do average rate of change? Okay. So we make a table, right? These are our inputs. So we just make a little XY chart. So I have an input of -3 and an input of 0. When x is -3, what is my output? 2. When x is 0, what is my output? Okay. Remember, we subtract outputs first. What is 4 minus 2?
2.
Over inputs. What is 0 minus -3?
Positive 3.
It's +3. Minus a negative makes it positive. Okay. Let's do the same thing for 3 to 9. So I'm going to make a table. When x is 3, what is my output? When x is 3, my output is 6. And when x is 9, what is my output?
10.
Okay, so we subtract outputs first. 10 minus 6 over
9 minus 3.
9 minus 3. So 10 minus 6 is,
4.
and 9 minus 3 is,
6.
and we know that 4 over 6 reduces to,
2/3.
So, what do you know about the average rate of change over what? The whole function, right? It's 2/3 over the whole function. So that's something that we know about linear equations. Linear equations have a constant rate of change. Linear equations have a constant rate of change. Question D says, what is the function's y-intercept? Tim already told us. Say it again, Tim. It's the ordered pair 0, 4. And that is your warm-up.